Hi, let us understand how to set up Spark standalone cluster where I'll be setting up a master and n number of workers. To get n number of machines, I'm going to get the help of Amazon EC2 instances where I have started 3 machines. I'm going to consider one machine as a master and the other machine as a worker. And make sure all the machines are in the started state. I'm going to use this Spark master as a master machine which is of type T2 large where I'll have 2 core processor and 8 GB RAM. And I'm going to use 2 worker, Spark worker 1 and Spark worker 2, which is of type T2.medium where I'll be using it as a worker machines. The worker machines will be having 4 GB of RAM and 2 core processors. I'll be in a position to log into this specific machine using this public IP address. I'm going to use this public IP address, log into the master. And let me log into the worker machines as well. Let me note down the public DNS of the worker 1. Let me log into the worker 1. All 3 machines will be having the same typical installation, the Spark. I have unzipped it and I can start the worker accordingly. Within the Spark installation location in this particular machine, I have installed in this particular folder where I have a folder called sbin, where I have script to start the master and worker. I can use the other scripts like start all where I need to set up the slaves where and all the slave machines are available. Let's not worry about that. That's going to be the responsibility of the administrators to have the setup. I'm going to start the master. So the master will get started and that will provide a URL to connect with the master. We can verify the URL where it is running by accessing the web UI which runs in port 8080. The public DNS and 8080 will give the status about the master. We don't have any workers attached to this master. This is the master URL. Let me start the workers by providing this as the master. So in both the worker machines, I'll be starting the slave processes /sbin start slave.sh and I'll provide the Spark URL. It ends with 7077, that is the default port where Spark communicates. The worker will get started and it will get attached to the master running in this specific machine. This IP address is the private DNS of the master machine. That very well we can identify over here. That's the private DNS. And AWS communicates internally using the private DNS. And whenever we are starting n number of machines, make sure your security group allows the other machines to communicate with each other. How I can provision that? Open the required port for all the machines running with the security group. If you type in ESG, so this is the security group where I have allowed all the machines running with this security group will be in a position to communicate in all the ports. And I have started all the machines to use that specific security group. Apache Spark, the key name, and the security group Apache Spark. Now I have started a worker. If I refresh, I should be in a position to see one worker attached to this particular machine. Let me start another worker as well. /sbin start slave.sh and point it to the master URL. So the next worker will get started. Now I have a standalone cluster where I have one master and 2 workers. I have a Spark master and the worker reporting to the master. Now I can submit application to this particular cluster. Submitting the application, I can use a command called spark submit or even I can start the Spark shell application by connecting to this particular master. We will see both the options. First, I'm going to submit the Spark application using a cluster mode. As we discussed earlier, whenever I submit an application, that's going to start a driver program, and internally it will be maintaining the Spark session. And prior to Spark 2, it used to maintain it as Spark context. I'm going to submit an application in the cluster mode and see how it behaves. I can submit from any application as long as I have access to the master URL. I'm going to submit a sample Spark application that comes along with every Spark installation, a class called Spark Pi, which will calculate the value of pi. You see ./bin/spark submit. I'm going to submit an application. So this is going to be a class file within a particular jar file, and how that particular jar file is generated. So jar file can be generated by multiple means. I may have a number of Java file where I'll be compiling the Java file, make it as a class files, and package them as a jar file. To achieve this process, I can use a tool called Maven or Gradle. And if I have a number of Scala files, I can compile all the Scala files as a class files. Scala, on compiling, it's going to generate the bytecode instructions equivalent to what gets generated within Java. So within the same JVM, we can execute the Scala class files as well. And packaging all the class files will provide me a jar file. I can use a tool called SBT, Simple Build Tool, to create a jar file. We will see the process of creating the jar file using Java or Scala later. I'm going to use the jar file provided as a part of the example. I'm going to use a class Spark Pi, which will calculate the value of pi. I need to provide the master. And if I'm going to submit this particular job in the cluster mode, I should use this particular URL as master, the REST URL, which runs in the port 6066, where it clearly mentions whenever I want to use the cluster mode, I should use this specific URL as the master. And the deploy mode, I'm going to mention explicitly saying cluster. And in the same installation location, I have a folder examples, jars, Spark examples, that jar. And I'm going to use 5 partitions or 5 sample data to calculate the value of pi. As we discussed earlier, whenever I submit a job in the cluster mode, the client doesn't need to be in touch with the driver. So immediately after submitting the job, the client will come out and it can continue with its own work. So let me submit the job. So job got submitted, and it provided a JSON response saying it got submitted. I should be in a position to see the response. Yeah, it got over so fast. One driver got executed and one application got executed. Let's submit this once again and quickly verify. So one application is running and one driver is running. It can run in any one worker. You can automatically choose the worker which is having enough resource, and the application, it can spread across n number of machines. That also got over. We can check the status of the application over here. Now let us submit the application using the client mode. So for the client mode, the only difference is the master URL, it will be pointing to the port 7077. Spark submit, the class file, and master URL, port is 7077, and deploy mode is client. The client will be in connection with the driver, and it keeps logging the input or the data provided as a result. So I'll be in a position to get the value result back and get that printed. So the main difference between the cluster mode and the client mode is whether the client will be in touch or in connection with the driver till the end of that particular program or not. And we have the cluster up and running where I can start any applications or I can submit any application.